In this lecture, we're going to talk about radical equations and specifically the concepts of solving radical equations. And when I say the concepts, most people just jump right into solving radical equations, but I think it's important to understand the concepts behind everything you do. Don't just mimic what somebody does. You actually should know why something works the way it does. You should really look for patterns in mathematics, and that's what I'm going to try to make apparent to you with this video at least. Prerequisites, you have to know a lot of the stuff about radicals, specifically all the prerequisite radical information. Any video that I have on radicals, pretty much you should watch those first. You should be able to solve an equation with one occurrence of a variable and then solve quadratic equations as well. So let's first define a radical equation. A radical equation is just an equation containing one or more radicals. Simple examples of these would be stuff like this. 3 times the square root of x is equal to 17. 3 times the square root of x plus 1 minus 4 is equal to 83. 3 times the square root of x plus the square root of x minus 1 is equal to 72. That type of thing. It doesn't just have to have one radical, it could have a couple of them. But specifically, this is the definition that a lot of people quote, but really, when I say it contains one or more radicals, really it means contains one or more radical expressions that have unknowns in them. So notice that each of these equations has a variable underneath the radical. That's what makes them a radical equation. And we're going to concentrate on solving each of these. Now there's really two types of methods here to solving radical equations. One is the method I've always taught, and I'm going to go ahead and go over that again here. So here we go. This is my method, my patented method. This is really not my patented method, but it's a method that I haven't seen a lot in textbooks, if ever. Okay, when solving any type of equation, it doesn't matter what kind of equation you're solving, honestly, whether you know the kind of equation or not, even if it's a trigonometric equation or an equation in calculus, this is the basic idea. Clear fractions using the LCD or clear decimals by multiplying by a power of 10. Once that's done, you should have integers on as your coefficients. And those are just easier to work with. Clean up each side of the equation by getting rid of parentheses and combining like terms on the left hand side and on the right hand side. And then at that point, if you look at your equation and there happens to be variable terms on both sides, move all the variable chunks to one side. And then there's one of two things will be true. Either it leaves you with only one occurrence of your variable, then in that case you do my untie the knot method. Otherwise, if you have two or more occurrences of your variable, then you have to resort to special techniques. I'll show you what I mean here. So our first example, I'll just take a basic example. It's called a linear equation because, well, all the powers on x are just 1. And I look through this and I say, oh, they're fractions. So the first thing I'm going to do is multiply both sides by the LCD. Looking at all the fractions in this, the LCD is going to be 6. So I'll multiply both sides by the number 6. That's without me really thinking here. I just immediately do it. So I'll distribute the 6 to each term. Notice on the left-hand side, there are actually only two terms here. This first term and the second term. So I distribute the 6 to each of those. On the right-hand side, I distribute the 6 to all three terms, actually. Remember, terms are separated by plus or minus signs. We have 1, 2, and 3 terms. Doing that, 6 times 1/3 will give me 2, so I'll get 2 times the quantity x minus 6 plus 6 times 7 is 42. X is equal to 6 times 2x is 12x. 6 times the negative 1 is a negative 6. 6 times 1/6 is just 1. And now we are at a point where we no longer have any fractions. Now I clean up each side by distribution and combining like terms. So the distribution here, 2 will distribute to x and to the negative 6 there. And, well, that 1, I guess you could say that 1 distributes. It doesn't really do anything, honestly. So we get 2x minus 12 plus 42x is equal to 12x minus 6 plus x plus 4. Combine like terms on each side. I have 2x plus 42x is 44x minus 12. 12x plus x, that's 13x. Negative 6 plus 4 is a negative 2. And now I see at this point, now that each side is clean, I see both sides have variable terms. So I'm going to move them all to the left-hand side. So I'll subtract 13x from both sides to get 31x minus 12 is equal to negative 2. Oops, that's supposed to be a 2, but I accidentally miswrote it. And at this point, most people know how to solve this, but I'll show you what I mean by the untie the knot method. When you're solving an equation, it really is just that you're looking at inverse steps. So somebody, at this point, you can consider that somebody hid the value of the unknown from you. They tied it up in a knot. They multiplied it. The first thing they did was they multiplied it by 31. Remember, follow the order of operations. So you look at x, and following the order of operations, you say, is there any powers? Are there any powers on it? Nope. Is there any multiplication? Yes. So they multiplied it by 31. Is there any division? Nope. Is there any subtraction? Yes. Or addition. So they subtracted 12. Those are the two things they did to hide the value of the unknown. To undo that, you can consider them tying x up into a knot by multiplying it by 31 and subtracting 12. To untie a knot, you start with the last thing that was done, which would be this right here. So we're going to undo that, and by basically untying it or doing the opposite of what they did. So the first thing we're going to do is do the opposite of subtraction by 12. We're going to add 12. Second thing we'll do is the opposite of multiplying by 31. We're going to divide by 31. So that's our roadmap. So here we go. We'll add 12 to both sides. We get 31x is equal to equal to 10. I was going to say 14, but that's not true. It's equal to 10. And then I'll divide both sides by 31, and that'll give me x is equal to 10/31. And I'm done. And this was just solving a basic linear equation and using this information here. Clear fractions, clean up each side. If there are variables on both sides, move to one side. And then one of two things happens. Either you end up with just only one term involving your variable, or you have two terms. This is a case where you have one. Now, what happens if you have two variables? Well, and what would that look like? Let's just make up an example, like, and this will be a quadratic. Let's suppose somebody handed us something like 3 times the quantity x minus 2 being squared is equal to x squared plus 1. The first thing I'm going to note here is that I have to clean up each side. I can't just, there's two different versions of my variable here. I got to do a little bit of work. So I'm going to multiply out this x minus 2. So that's 3 times x minus 2. There are no fractions, so I don't have to worry about that. So I'm just rewriting this. I'll distribute out that x minus 2, so that's 3 times x squared minus 4x plus 4. And again, just showing you kind of all the little steps. Distribute the 3 through. It's not equals, it implies. 3x squared minus 12x plus 12 equal to x squared plus 1. And now that I've distributed through, I'm going to see if I can combine like terms on the left-hand side, and no, I cannot. I'll see if I can combine like terms on the right-hand side. No, I cannot. But I see I have two versions of I have versions of variables on both sides, so I have to move them all to one side here. Subtract x squared from each side, and I get this. 2x squared minus 12x plus 12 is equal to 1. Once I see that I have two different versions of my variable, I know I'm going to have to resort to special techniques, which means that I can't just say what happened to x and undo that business. Essentially, it means that either, well, in this case, since I have a quadratic, I have to resort to special techniques to solving quadratics. And one of those is factoring, the other is using quadratic formula. And for those who have mean teachers, you can use completing the square. So I'm going to try using the guess and check method to factor this, I have to isolate everything on one side and get 0 by itself on the other. So I'm going to subtract 1 from both sides here, just to get this completely in quadratic equation standard form here. And now I will try to factor this if I can. If I can. I'm not saying that I can, though. Either this is 11 and that's 1, which gives me 11x and a 2x. That's not going to work. Actually, I shouldn't have done that. I should just erase these. Or the first group has the 1 and the second group has the 11. That would give me 22x and 1x. That won't become 12 either. So this does not factor. This is completely unfactorable. That means quadratic formula time. X equals the opposite of the middle coefficient, so that's a positive 12, plus or minus the square root of that middle coefficient squared minus 4ac, all over 2a. If you can't tell, I have a little cold. Sorry if my voice is really raspy. Okay, 144 minus, let's see, this is 8 times 11 minus 88. All over 4. You get the point. I mean, we've solved this stuff before, right? 54 plus an extra 2 is 56. So it's 12 plus or minus root 56 over 4. And I'm bored with it, dot, dot, dot. Okay. The idea is that because we had two different versions of our variable, here we had to resort to special techniques. Now the same idea that if when we simplify or clean up both sides of the equation, if we end up with one term involving our variable, we can kind of undo that. That still holds for radical equations. Same thing for radical equations. If when I clean up both sides of a radical equation, if I have two different terms involving my variable, I'll have to resort to special techniques. Luckily, the special techniques with radical equations are actually not too horrible. So let me write that down. Actually, there's no real reason to write it down. I have it right here. When solving a radical equation, clear both sides of fractions or decimals. Clean up the left and right hand sides if you can by getting rid of parentheses and combining like terms. If there are variable terms on both sides, move them all to one side to see if they combine. If they do combine, that means, in other words, if you only have one occurrence of your variable, untie the knot. If they don't combine, then you have to resort to special techniques. And the special techniques for solving radical equations is as follows. And let me reiterate before I mention this technique that you only use a special technique if you have more than one term involving your unknown in an equation. If they don't combine, basically. But otherwise, you just untie the knot. Okay, so special technique for solving a radical equation involving two or more terms with unknowns that do not combine. You isolate one of the radicals, square both sides. Rinse and repeat. In other words, keep isolating a radical and squaring both sides until all radicals disappear. So you isolate a radical, square both sides, that'll clear out one of your radicals. Then you'll have one radical remaining, or depends on how many radicals you started with. You move everything to one side to isolate that radical, square both sides, you will have no radicals left. But the main thing about radical equations, no matter what, even if it's a special technique or not, you must check your solutions. You must check your solutions. Why? Because squaring both sides of an equation, doesn't matter if it's a radical equation or not, just squaring both sides of an equation always runs the risk of introducing a fake solution, or what we call extraneous solutions. So if you are ever reading a textbook and they say, notice that this is an extraneous solution, it means this is a solution that is extra and not good. Somehow a solution got introduced that wasn't supposed to be there. Now let's be real conceptual about this. Let's just say we have the square root of some junk with x plus some number is equal to some other number. And I'll put that as number prime because We don't know. The idea here is the only thing that we don't know is this x value. I mean, I'm just saying junk with x. It could be 3x plus 1, whatever it is. So the idea here is to untie the knot. You start talking about how do you undo all this stuff. Well, the first thing I would probably do is move this over there. So when you do that, you subtract whatever that number is from both sides. You get square root of that junk with x. Notice I'm trying to keep this as general as possible. Is equal to some number. Okay, I'm putting a little double hash mark on there so you know it's not the same as these two numbers. And now the problem is that junk with x is all mixed up underneath the square root. So I'm going to square both sides. Here I go. Notice I don't even need to know what these numbers are right now. So I'll square both sides. On the left-hand side, I get, well, that junk with x, it completely opens up because a square, squaring a square root, they undo each other. And so I get my junk with x is equal to some number over here. And now I can solve for x. Because this junk with x is probably really nice, like 3x plus 1 or x squared minus 5x or something like that. So that's pretty okay. Now let's suppose instead that you have square root of stuff with x plus the square root of junk with x, and that's equal to some number. If these two things aren't exactly the same, you cannot add them up. So notice this term here, if it doesn't have the same stuff underneath the square root as this second term here, then you can't add them up. It just can't happen. So this means we have two terms involving our x that cannot be combined. So we have two different versions of our variable x. And remember what I said over here, that once you get variable terms on one side, one of two things happens. Either you only have one occurrence of your variable, or you have a couple or more occurrences of your variables that can't combine. If that's true, you could move on to special techniques. And the special techniques for solving a radical equation means isolate one of the radicals, square both sides, rinse and repeat, check solutions. So let's isolate one of the radicals. Let's just isolate the stuff with x. Like how I say that? Yeah, so I'll keep this on the side by itself, on the left-hand side. Stuff with x here equals, and I'll subtract that junk with x from both sides. The square root of junk with x from both sides. Junk with x. Now I'm going to go ahead and square both sides. Very conceptual approach. Notice on the left-hand side, the square and the square root kill each other off, and I get to open up the stuff with x. On the left-hand side, I'll get number times number, or in other words, that number squared, minus some new number times the square root of junk with x. And then finally, negative root junk with x times a negative root junk with x becomes a positive, well, square root times square root becomes a full power, so just a positive junk with x. Now, take a look through this whole entire thing. By the way, if that was too confusing for you, substitute a number like 3 minus the square root of x. If you square that, you'll see it's 3 minus root x times 3 minus root x. Sorry that I'm writing so quickly. 3 times 3 is 9. 3 times a negative root x is a negative 3 root x. Negative root x times 3 is another negative 3 root x. And then negative root x times a negative root x is a positive just x. These two terms will combine nicely, so you have 9 minus 6 root x plus x. Notice it's just this form right here. Number, some number times the square root, and then the junk with x as well. Now, how many radicals do I have in this equation? The answer is 1. So I'm going to isolate that radical by moving all this junk with x and this number, everything, to one side except for this square root. So I'll end up with the square root of junk with x equals, let's see, mess with x. In other words, I don't know what all the operations are, right? Because this could be a 5x plus 7. This could be a 25. This could be a 9x minus 3. Once you move things over, you'll have a bunch of mess over here with x. But the idea here is now when you square both sides, you'll get rid of all square roots. So once you square both sides here, all square roots will be gone. And you'll be able to solve the equation for x. So that's the concept behind this. Now, I know that may seem difficult at first. What you should really do, honestly, is after you watch this video, watch the actual video on how to solve radical equations. Then come back and watch this example again, and you'll realize, holy moly, that's all it is. I don't really care what these numbers are inside stuff with x or junk with x. It really is just this. You isolate one radical, square both sides. Isolate the other radical, square both sides.